Hello class, and welcome once again. This is Mr. Dubé, and today we're going to be going over Unit 12, Day 3, Correlation and Linear Regression. So correlation is one of those very cool topics. Take a minute, quick, pause the video, and take down these notes. A correlation coefficient is a mathematical tool used to describe the strength and direction of a linear relationship between two variables. Kind of wordy. The way I like to think about it is it's the strength of connection. So I can either have a strong connection or a weak connection. I apologize for my writing. So we have these three cases here. For these purposes, right now I'm going to be defining my correlation as R. So R is going to be equal to my correlation, just a lowercase r. And R is going to be between -1 and +1. So while R exists between -1 and +1, it'll be doing different things between those two values. As R exists less between -1 and 0, it's what we call a negative correlation. As R is closer to -1, the stronger the correlation. So on a graph, we could see that my data points would be decreasing. My data points would be decreasing, and that would have a negative correlation. My data points are nice and tight together. It almost looks like a line. In the case where R is equal to 0, it's going to be the case where there is no correlation. So the way I like to think about it is it looks like a snowstorm. There really isn't any connection between my variables. As x increases, I really can't tell what y is doing. The final case occurs when R exists between between 0 and +1. As R is positive, we see that the closer it gets to +1, the stronger the positive correlation. So here we have the case where R is increasing. So as my x values increase, my y values increase. And for a strong connection, they're very tight together. They almost look like it's a line. So let's go ahead and take a look at this first example. Example 1. Which scatter diagram shows the strongest positive correlation? So looking back at my notes, I know if it's a positive correlation, I know that it's going to be between 0 and +1. And if we're looking for a strong correlation, it'll be very close to that 1 value. So when we're looking at the scatter diagrams, I want my points to be increasing, and I want them to be very tight together. Let's look at A. Here it almost looks as if as my V increases, my KE, it almost looks as if it's staying constant. It almost looks like it's just going at a horizontal line. So I want to call that a positive correlation. What about B? As my KE increases, it looks like that my V just stays the same. It looks like it's hanging out just at that 1. That would be similar to a vertical line. So we still haven't found a positive correlation yet. Let's look at C. As V increases, KE actually decreases. So if this question was asking for a strong negative correlation, that would be our answer. But no, it's pretty obvious that the answer is D. This would be a strong correlation because my data set is as my V increases, my KE increases. So both sets of data increase together. And they're very close. You see that it almost looks as if it's a line. Take a moment and copy down these notes. Let's take a look at another example. What could be approximated value for correlation coefficient for the accompanying scatter plot? So let's first look at the scatter plot. I see that my values are very tight together. So I would say this is strong. Now I want to pay attention to see if it's positive or negative. I can tell that as my x values increase, my y values increase, so that would make it a positive correlation. So I'm looking for a strong, positive correlation, which means that so I know that my r values will exist between 0 and positive 1. And I'm looking for the case where it's very close to positive 1 because it's strong. So obviously my answer should be 4. Very good. Take a moment and copy down whatever notes you think would be necessary. Example number 3. The points in the scatter plot represents the age of an automobile, my first variable, and their value. So let's take a look at the scatter plot before we start answering the question. So we can see that in my scatter plot, as my age increases, my value in dollars decreases. So we can already tell they're going to be having some type of correlation, specifically a negative correlation. And next I want to focus on how my scatter points are connected. We can see that they're not very tight together, so I wouldn't say it's a strong correlation. But we definitely know that we have a negative correlation right now. So let's look at A. The age and values have a coefficient of correlation that is greater than 0.5. So what that says is that R is going to be greater than 0.5. So what do you think? What does that describe? Well, that would describe a positive correlation. But does that make sense that as a car gets older, its value in dollars increase? Yes, in some cases, maybe with a luxury car from the past. But when we look at the data, it doesn't show that. It shows that as my age gets older, my value goes down. So number 1 wouldn't be the answer. Let's take a look at number 2, where my coefficient of correlation is between 0 and 0.5. So 0 less than R less than 0.5. So still, this describes a positive correlation, but it's going to be a weak correlation. So I don't think 1 or 2 would describe this scatter plot. Number 3, age and value have a coefficient correlation that's equal to 0. So this is the case that we said we had a snowstorm. But when we look at our scatter plot, I don't think that really represents a snowstorm. I can definitely tell that as age and years increase, my value decreases. So no, I still don't think it would be a no coefficient. No correlation, I misspoke. No correlation. So 4 is our last choice. Let's see if it's true. Age and value have a coefficient of correlation that is less than 0. So R is less than 0. This would be the case. This is this case when we have a negative correlation. So as I repeated multiple times, this is the case when age increases and the value in dollars decrease. In fact, I would almost even say that this is a weak correlation. So that finishes up correlation. Let's take a look at linear regression. So what I would like you to do is go ahead and copy down these notes into your notebooks. I think it's important that we know the calculator steps for finding our linear regression and correlation coefficient. So a linear regression is the equation of the line of best fit for a set of data points. So you may have heard of line of best fit in the past, where you would be making an approximation. The cool thing with these graphing calculators is that it'll find the best line of best fit. It'll find the most exact approximation for our set of data. So it's going to be very similar to the steps we did in the past. We're going to need first create a list. But here's the important part, that we need to be labeling our list. We need to be labeling column A and column B. And I like to usually give them the titles X and Y. That's going to be important later because when I graph my scatter plot on the graphing calculator, I already know what is my x-axis and what is my y-axis. So once we're in our graphing calculators, we're going to be able to take a look at the variables of the linear regression. I'll be able to actually get specific values. So those specific values are listed right here. I'll be able to know that my linear regression is going to be of the form y equals mx plus b. We've actually seen this in the past. This is just the equation of a line. We call this a linear regression because it's describing the line of best fit for a set of data points. So with the linear regression, which is made up of a slope value, m, the rate at which it's either increasing, decreasing, or staying constant, and a y-intercept, where across the y-axis. Finally, we already defined r, but on our graphing calculators, we'll also see that the correlation coefficient is equal to r. Take a moment, pause the video before it ends, and copy down these notes into your notebooks. Tomorrow, we'll be sure to go over an example of how to find a linear regression using the TI Inspires CX. Thank you, and have a great evening.